arithmetic sequence is a sequence whose consecutive terms have a common difference. Consecutive terms of an arithmetic sequence have a common difference. So what's the common difference in our arithmetic sequence 5, 8, 11, 14, and 17? They're all 3, okay? There's a difference of 3. Positive 3 or negative 3? Positive 3 because we're getting bigger, right? All right, so that is a signal that we have an arithmetic sequence. What's the common difference between 11, 95, and 5/10? 91, 86 and 5/10, 82, 77 and 5/10, and so forth and so on. 4.5 positive or negative? Why negative? Because we're going down. Okay, makes sense? Our numbers are decreasing in our sequence, it's a negative common difference. Our numbers are increasing in our sequence, it's a positive common difference. Okay? So I want you to think about an arithmetic sequence like a linear equation, because I think it helps to connect it to previous knowledge. Think of your common difference as the slope to a linear equation, and think of the letter C, which is going to be in this explicit definition, as your y-intercept. Okay? So your explicit definition for an arithmetic sequence is a sub n is equal to dn plus c, where d is your common difference and c is like b of that slope y-intercept form. You have to take your first term and take away a difference in order to figure out what your zero term would have been. Okay? So if you can make that connection in your mind, life will be easy when it comes to common differences, because you're very good with slope and y-intercept. Make sense? Okay, so we want to write an explicit and a recursive form for the sequence 5, 8, 11, 14, and 17. We already determined that that has a common difference of 3. Okay, so D is 3. Okay, what would our zero term be? Our first term is 5, so our zero term, if we back it off, we'd get 2. Yep, take away one more difference and you got your zero term. Okay, so when you want the explicit form, a sub n, it's going to be the common difference times the term number plus our zero term. Okay, what would its value be one step back from the beginning? Make sense? Let's try some numbers. If we plug in 1, 3 times 1 for our first term, we get 3. 3 plus 2 is 5. We plug in 2 to find the second term. 3 times 2 is 6. 6 plus 2 is 8, and so on. Explicit definition. Make sense? Okay, let's talk about recursive. Remind me what recursive is about. Recursive sounds like reoccurring, right? So what do we have to have when we write a recursive formula? What do we have to have if we write a recursive definition? Remember from yesterday? Yep, it has to know how to handle, how to generate itself from the previous term. So we always have to define the first term, right? So we say a sub 1 is equal to, what's our first term here? 5. And then how is each sequential value or element found from there? take the previous one, right? And do what to it? Add 3, our common difference. Okay? So that's one way of writing that. Okay? Another way of writing it is to say a sub n plus 1. What's that? The n minus 1, it says if you're finding the second term, take the first term and add 3. If you want the third term, take the second term and add 3. I think our book is actually going to call it n plus 1 if you want to generate the next term. Take the previous term and add 3. Okay? I've seen it both ways. I don't care which one you give me. Okay? Does that make sense? Either I kind of like this one better. If you want the next term, take the previous term and add 3. But I also like this. This makes logical sense. If you want the fifth term, take the fourth term and add 3. They're equivalent. Okay? So two people may have two different answers and they may both be right, and that's okay. Make sense? All right. Questions on this one? Good? Okay. So for the arithmetic sequence, a sub n equals 2, 9, 16, 23, and 30, and continues on, so it's an infinite sequence. I want you first to A, find the common difference, then B, find the explicit definition, C, find the 10th term, and then D, find the recursive definition. Give you some time to work. Is that that? Yes, that's perfect. Okay, now find C. It's got to be that, right? Oh, I'm sorry, you switched them. Okay, no problem. No problem. Good. Careful on this one, because we're increasing, right, by 7. So we have to back it off by 7. If we take 7 away from 2, what do we get? Good. So that should be your -5 there. Thank you very much. Good. Okay, I'm sorry. 2 come. Gotcha. Go. Okay. All right, so we found our common difference was 7, correct? Okay. And that means that if we're going to write our equation, we need to back it off by 7. So 2 minus 7 is going to be a -5. So our explicit definition is a sub n equals 7n minus 5. And then our 10th term, once we have that, we just substitute 10 in everywhere we see n. So a sub 10 will be 7 times 10 minus 5. So 70 minus 5 is 65. 10th term is 65. And then part D, we were to find the recursive definition. So the recursive definition says, hey, tell me what the first term was. A sub 1 was 2. And then what are we doing to each one? If we want the nth term, or a sub n, you take the previous one and you add on our common difference. Or you could have said a sub n plus 1 is a sub n plus 7. It gets you the same thing. Okay, got my first term. If I want my second term, I take the first term and add 7. If I want my third term, I take the second term and add 7. Okay? Okay, good question. So we're okay with this being 7, right? Okay. And if we put a plus 2 here to start with our term, we'll be too far up, because 7 times 1 is 7, plus 2 would get us 9. So that's going to get us our next term. So we got to back it off 1. What's that? Right, not supposed to reach the next one when we put in 1. When we plug in 1, we want to get a 2 back. So in order to get a 2 back, we have to take away 7 and figure out what our 0 term would be. A negative 5 is back here. Okay, our explicit definition said that C is equal to our first term minus the difference. Okay, this number is going to be your first term, take away 7. Okay, make sense? Other questions on this one? Okay, so now we get to play with it a little bit. Make it a game. And say the 8th term of an arithmetic sequence is 25, and the 12th term is 41. Tell me what the first 5 terms are. Eighth term is 25. 12th is 41. Can you come up with a sequence? I know of at least 2 ways to look at this. Okay? The 12th term is the same thing as the 8th term, but with how many more differences added on? How many differences? So we have first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term, 11th term, 12th term. 4 differences, right? Okay, so we know that we have 4 differences between these guys. We don't know what our difference is yet, but we know there's 4 differences there. So if our 12th term is 41 and our 8th term is 25, and we have 4 differences between them, how can we solve that? Subtract the 25. So 16 equals our 4 differences. So how much is each difference? 4. Okay. So far, so good? Okay. Now we've got to come up with an arithmetic sequence here in order to make this happen. Okay. Between the first term and the 8th term, there are how many differences? because we could simply subtract 4 each time and fill in the blanks, right? And that's a strategy, but is it the most efficient strategy? Probably not, right? Okay. So between the first term and the 8th term, how many differences are there? One, two, three, 4, 5, 6, 7, right? Okay. So there are 7 differences. Okay. So the 8th term, a sub 8, is equal to the first term plus 8 or 7 common differences, and our difference is 4. Okay. Our 8th term was 25. Seven times 4 is 28. So what's our first term? -3. So -3 is our first term. Our common difference is 4. What's our second term? What's our third term? And our fourth? And our fifth. So if we were writing that sequence, if we wanted to write the explicit form, we need to figure out what our 0 term would be. So we want to take away another 4, and a sub n would be 4 common differences plus, and then -3 minus 4 gets us our c, so plus a -7 would be our explicit formula. Questions on this one? Okay, feeling confident? May not hurt to fill out the blanks, just until you get confident and comfortable with this. Okay. All right, next one. The sum of a finite arithmetic sequence is obviously, if it's infinite, we're never going to be able to sum it up. These numbers we keep adding common differences and get further and further away from our beginning of our sequence. But the sum of a finite arithmetic sequence is given by the formula S sub n is equal to n over 2 times the first term plus the last term. So if we are asked to find the sum of 40 plus 37 plus 34 plus et cetera, down to 22, that's a finite sequence because it stops. Okay? So if I want to find the sum, I have to first of all know how many terms there will be. Does that make sense? Sum of n terms. So what's our common difference here? 3. Is it +3 or -3? Because we're going down, right? Okay. So our common difference is -3. We could probably fill in the gaps there, but if it was a very long sequence, we wouldn't be able to fill in the gaps very easily. So let's come up with our explicit formula for this. What would the explicit formula for this particular sequence be? -3n, right? And if we minus a -3 from 40, what would be the 0 term? 43, right? Okay, it'll be bigger. Okay. So if we had a big gap here and had to calculate this manually, we could see that we can plug in 22 would be equal to -3 times some term number plus 43. When we take away 43 from 22, what do we get? Negative 21, right? So if a negative 21 equals negative 3n, we have how many terms? 7. 22 is our 7th term. Okay. Now we can apply our sum of 7 formula. Okay. The sum of 7 will be equal to 7 over 2 times the first term, which we knew to begin with, and the last term, which we knew to begin with. We just didn't know what n was. So 40 and 22 gets us 62, right? We're taking 62 times 3.5, and what do we get? One's 217, right? Okay. So if we added 40 and 37 and 34 and 31 and 28 and 25 and 22, do we get 217? Questions on that one? Make sense? All right, last one. Find the 50th partial sum of this sequence. So it's one that goes on forever. It's an infinite sequence. We want to know what's the 50th partial sum. So we know n is 50, right? Do we know our first term? First term is negative 6, right? Do we know our 50th term? Nope. So what do we have to do? Explicit definition. Let's find the explicit definition for this guy. So first piece that we need to know is what is the common difference. So we're adding 4 each time, positive 4. Okay, so difference equals 4. If we take away one difference from the first term, let's see. All right, so explicit definition, you can use A or B, it doesn't matter, but we want our nth term. We're going to take our common difference times n and take away 10. Now can we find the 50th term? Plug in 50 everywhere we see n, right? So a sub 50 is 4 times 50 minus 10. 200 minus 10 is 190. So our 50th term is 190. To find the sum, the 50th partial sum of this, we need to take our n, 50, divided by 2, times the first plus the last. First term was negative 6. Last is 190. So 184 times 25 gets us what? 4,600. Do you see how the ACT scores for those who know sequences in series goes up compared to those who try to manually plug these numbers into a calculator forever and ever and ever? Much faster this way. Okay, so 4,600. Questions on this one? All right. Your assignment.